Welcome, everybody. My name is Earl Beede. I'm a senior fellow here at Construx Software, and I'm here to talk about the 7 signs of a well-prepared estimate. I'm backed up by Jenny Stewart and Jesse Bronson in the back room, looking at your Q&A and helping you with any technical issues going forward, but I'll be your main face for this presentation. Well, welcome to my home. This is, of course, coming the time here, and I'm in Washington State in the USA, and we're in the middle of our stay at home to fight the coronavirus. So welcome to my house, where it is actually lunchtime. For those joining from the rest of the US, hopefully you're all safe and sound as well. In fact, the rest of the world. So it's sort of afternoon drink time in the East Coast, dinner time in Europe. So hopefully you can get something out of our lunch and learn here. A couple things before we get going. One of the things is about the Construx Lunch and Learn program. This is actually something we've been some experience with. We've been doing webinars for years, of course, but this particular Lunch and Learn is sort of an outgrowth of something we tried in 2009. For those who remember, 2009 was the dot-com crash and the Great Recession. Well, we did the dot-com crash, but also did it for the Great Recession. Because so many people are out of work in both those things, we started seminar programs. We started the Spear at the dot-com crash of 2009, and we did a similar thing after the Great Recession. And also, we started to work on saying, what can we do now that everyone's stuck with these massive work from home section of the coronavirus? And so we brought back Spear for 2020 Lunch and Learn. One of the things we want to do in this Lunch and Learn is to create a community of people that says, while I'm stuck at home in particular, there's other people out there, other resources I can get to help me develop great software. And so we want to sort of build this community of software professionals who are all working from home, who can start interacting and learning together. So we're doing this all through the month of April. And if the thing extends into May, we may consider doing it for May as well. But right now, the end of April seems pretty good. So we've got another couple weeks of these, so share these with your friends. You can find out more of them down at the Construx Lunch and Learn or www.construx.com/lunch. Also, we'll have all of these in our on-demand environment as well. In our on-demand environment, you can find this Lunch and Learn, all the previous Lunch and Learns, plus lots of great seminars that we here have at Construx to help you build better software and run better teams. So all that's available to you there as well. So check out this and share it with your friends. A little Lunch and Learn tech before we get into our presentation here. We have a full ability to Q&A. You should see a little button up there that looks like that yellow Q&A button. It's not yellow, it's clear, but I wanted to jump out here. And that's where Jesse and Jenny are really sitting out waiting to get your questions. So ask them at any time and they can respond to you in almost real time. This presentation using webinar technology is a little ahead of you. That is, I'm probably 20 to 30 seconds ahead of where you are seeing things right now. So when you ask a question, they can still get back to you in real time. The Q&A is still in real time, but where I am in the presentation might be a little bit further along. So make sure you understand you mentioned where we are with your question. The other thing, though, is because we're using Teams live event software, is that you can pause the presentation anytime. That is, if you need to step out and go do something, just pause the presentation, go do your thing, and then pick right back up where you left off. You could even go back in time, if you will, and play something again. It just gets you further behind where I think I am, that's all. And if you're working it and you notice the presentation seems frozen, well, maybe you paused it accidentally. That's really easy to do if you're using the web interface, because the web interface, you just use the space bar to pause it. And some people tap that accidentally. So if you think it looks frozen, that's a good chance that maybe you paused it. So put questions in wherever you want, and you can pause and go back, or you can try to catch up with what's currently live. So what's our agenda or our courses for this lunch here at my family room here? Oh, and by the way, it is Tie Tuesday, so that's why I'm wearing a tie. This was long before Jimmy Kimmel started doing this Formal Friday thing. Tie Tuesday's been around forever, and I'm a bow tie kind of guy, so Tie Tuesday, let's do it. So what's our courses here? Well, we're going to start saying, hey, I need to understand a well done estimate, because as a leader or someone receiving estimates, I need to know that this estimate is something I can trust to make decisions on. If I do not trust this estimate, I want to go back and get a better one. So what signs will give me that better thing? So we're first going to talk about where to look for signs. So I'm going to name 7 areas to look. And these are the 7 areas. Then we'll go through these 7 areas and look at them, from estimation probability to planning with estimates. And once we've got those 7 areas down, we'll sort of wrap it up and digest what we've learned and see how that sort of all wraps together. So let's start out by looking for signs of a well-prepared estimate. Now, the reason we want a well-prepared estimate is because it turns out that if we're working on a thing, right, if we're trying to plan out some work effort of some kind, if we're thinking about how to engage a whole team on something, if we understand the work correctly, and that's what estimation is doing. Estimation is saying, do I understand really what this work is? When I understand the work correctly and my estimate is smack on, that means I'm going to have the effort with the least cost, schedule, and effort. This can be my most efficient way to do whatever I'm doing, whether it's a 1-month small release or a 2-year large project. When I understand the work, that means I'm likely to get it the most efficient project I can. But getting that estimate up front is really hard, right? Because we know that estimating things is difficult and we're going to make a mistake. We're either going to overestimate over here, right, with time and cost. We're going to say we're going to give you too much time or too much money, or we're going to undersell the number of features we can build. Instead of saying we can build 30 features, we're going to say we can build 25 features. And we're going to pay a penalty for that. And the penalty for that is relatively well known. In fact, it has a name. It's called Parkinson's Law. Parkinson's Law is that law that says work expands to fill all available time. If we only promise 15 features and we could have really done 20, we'll end up delivering 15 likely. There'll be really nice 15, but just 15. Or if I gave you 3 months, you only really needed 2 months, you'll still take 3 months. That's Parkinson's Law at work. Work expands to fill all available time. And we believe Parkinson's Law. But you notice here in my graph, I do believe Parkinson's Law is a linear penalty. That is, for every week I give you, every feature I underpromise, that's just one thing. So it's 1 for 1, a linear line, very clearly done. What we don't have, though, is a good law for what happens when we underestimate. Because what actually happens when we underestimate? This is where I say, hey, we've got 3 months and we're trying to shove 6 months work into it. Or we promise to deliver 20 features, but we only have time to actually do 10, right? What happens when we underestimate? What happens over in this zone over here? Well, I think there's lots of things that happen there. I think these are some of the things that happen here. Mostly is that we cannot really make good decisions. That's what we mean when we talk about planning here. We talk about making decisions and coordinating people. And when we don't understand what's really going on, we don't have a clue about what we're doing, it's really hard to do that well. And so we'll have the wrong people at the wrong time in the wrong place. Lots of planning errors. And there's also the domino effect. And this is where maybe we can come up with Earl's theorem on for underestimation, because we have Parkinson's Law for overestimation. So I want to propose Earl's theorem for underestimation. Earl's theorem is late projects breed late projects, or late work breeds late work. That's the domino effect. If this one's late, that means that we're going to be running over and the things that should have started aren't starting and they're going to be late, which then breeds other people being late, the domino effect. But trying to avoid the domino effect, we start doing all kinds of crazy practices, risky things that we normally wouldn't do. Let's skip early activities like good discovery or or reasonable amounts of design up front, or actually any kind of planning, and just get to it. And we'll do other risky practices like, well, we won't do TDD, or we won't do a good acceptance criteria because we don't have time for that. Well, that just increases our defect. In fact, we've seen that just the thought of schedule pressure, right? Not just the reality of all these risky practices, but just the thought of schedule pressure can increase defects. My boss, Steve McConnell, talks about defects going up by a factor of 4x-ish, right? When we are under the illusion of schedule pressure, let alone if it's really true or not. All this leads to all kinds of things that we have to do near the end of the project, like the late cutting of scope. Happens all the time. Or we have to extend the schedule, then the domino effect goes in to a full effect. But what really gets me here is this idea of upset customers. I worry a lot about upset customers because on the other side, if I said I'm only going to deliver 15 features, well, I really could have done 20. I still am delivering 15 features and they're really well done. My customer's like, okay, that's what we agreed to. Or if I said it's going to take 3 months, I could have got it done in 2, but it takes 3. That's what we agreed to. No one's upset. But when I say, hey, you'll have it in 4 months and it ends up being 8 months, well, then I got these upset customers again. And I think that's really a big drive. It's not just our external customers, but our internal customers as well. So I think that's a real reason why we want to make sure that we have a really good estimate. Because when we have that good estimate, we're back down here saying we're going to avoid a lot of those errors and that high cost and that high penalty that we pay. And so what are the signs that I have good errors? Where do I even look for those signs? So these are the places I think that we look. I think there's 7 primary areas that we can look at to say that we have a good estimate or not. And I just want to go through these areas briefly and show you what kind of signs you would look for. I'll describe the area, and then I'll go through and say what signs you were looking for, what sign you should look for in that area to say, yeah, I've got a good estimate that allow me to make reasonable decisions to avoid paying any of those penalties. So let's look at area number 1 here. Estimate probability. Estimate probability, what's this all about? Well, it turns out if you think about an estimate is not just a single point in time. There's a probability distribution of some kind. So I've got my little grid up here, and on the left side I have probability of a specific date. So probability of a specific date does not get very high, like maybe 1 or 2%, because every particular date has some sort of chance. And the bottom of my line down here is time and cost. Time and cost is usually what people are estimating, though you can also estimate features. But for time and cost, the curve looks something like this. It's a distribution of some kind. And this curve, often known as a Rayleigh curve or Y-bill curve, it has a couple interesting aspects to it. One interesting aspect is that there is a minimum. The minimum says there is some minimum amount of time or cost any kind of work effort will accrue. In fact, the laws of physics say something like that. Now, if I was doing features, there is a theoretical possibility that I could deliver absolutely no features, sad as that may be. But it could happen. But most of the time, even there's probably some minimum amount of functionality that you can develop given the budget and the time you've been given. But most people are being asked, when will this be done and how much will it cost? And for that answer, there is always a minimum. The other end of the curve, though, that's really interesting. The other end of the curve is infinity and beyond, right? That is, you could take forever and you can use up all the money ever dreamed of to get this work done. Now, the probability as you approach infinity becomes really, really, really small, but it's still there. And so if you were to ask an honest estimator who's good at estimation, what is your estimate? What is your true estimate for this? They would say, well, it will cost at least this much, or it will take at least this much time, the minimum, right? And we could go on forever. Wow, how useless is that? Well, I guess maybe it's not entirely useless if the minimum over here was way too much already, but generally that's not the problem. So what an estimator does, if they look at really this as a probability distribution, what a good estimator will do is they'll pick a point on this estimation curve. And this point, which I'll label the estimation point right now, is just one point on the curve to express something to you, to tell you about this estimate. It's not the entire estimate because the estimate is the entire probability, but it's picking one specific point on this estimate to help you understand that. Right. Now, this particular point is interesting because this point is often called the nominal. And the nominal point is called that because if you did the math of the area of the curve, you would get 50% of the area over here and 50% of the area over here. That is, this is a point which divides the area under the curve equally. And this is really cool for statisticians and all those kinds of people because they do this kind of stuff for a living. And there's other reasons for it if you're really getting an estimation. But it's a very common point picked, the nominal point, the 50-50 point. Equally likely to go over as under because the area is the same. But it's not the only point. There could be other points in this curve as well, and we'll see that a little bit later. But the point here is that if you're going to ask someone for an estimate, the sign you should be looking for, the sign is say, can they name where their current estimate lands on the estimate's probability distribution? Are they picking the nominal point? Are they picking some other point? Do they even understand that there's a distribution, right? If they don't understand that, that's probably a sign that you have a bad estimate. And I'll even give you a bonus sign here as well, that they could talk about several estimation points. And here's where I like to talk about 3 points on that curve. The at least point, where it's not quite the minimum, but it's close to that, saying it's going to be at least this. So no one gets an idea that it's going to be any faster than something. So it's at least this. I don't like saying best case there because people think best case, well, I want the best. I'll take that one. I say at least, the at least point. Then there's the not likely to exceed. Some people like to call this the worst case. I don't like that statement because no one wants the worst, but I like giving people the comfortable saying we're not likely to exceed this much money. And a middle point. It's not my promise point yet. It's not what I'm guaranteeing. It's just a point we're going to use to start say how do we plan to make decisions around that. So as a bonus sign, if they can talk about multiple points, that's probably a good sign that you have been given a decent estimate. Again, if you have questions about this is a good time to queue up those questions with Jenny and Jesse so they can start answering them for you in near real time. And then picking out some good ones, we can talk about those again at the end of the presentation. All right, so that's area number 1. Let's go to area number 2, estimation accuracy and precision. What's this all about? Well, when we have an estimate, the estimates have ranges from low to high. And somewhere along in that range from the low value, small amount of time to high amount of time, low amount of cost to high amount of cost, somewhere along that line will be the true value. It will end up being the true value of what we actually spent or how much time we took. So how the true value relates to the estimate is what's important. Let's take a look at a few estimates here. So here's estimate number 1. Estimate number 1 is accurate. It's accurate because if I go back up from the true value, or just draw a line from the true value, you can see that the true value is incorporated in that estimate. That is, that estimate's range includes the true value. However, it's not very precise. That is, it's such a wide range, it almost covers the entire possibility spectrum. So it has low precision, high accuracy in terms of it contains the correct value, but low precision in terms of it's not very helpful, right? Because like, yeah, it fell on our scale somewhere. Compare this to estimate number 2. Estimate number 2 is also accurate. That is, so if we draw the line up again, we find that the true value ends up within the range of that estimate. But it's more precise than estimate number 1 because it is more tightly constrained. There's less in that range. Now compare this to estimate number 3. Estimate number 3 is inaccurate. Again, if we draw the line, nowhere near there, right? So it's inaccurate, but it has very high precision. And this is something that gets us in trouble all the time on estimates. A lot of time when someone asks for an estimate, they come back and they say, oh, here's an estimate. And what they've given me is the output of some tool, often an Excel spreadsheet, which they've made all sorts of interesting mathematical calculations in, and it comes out with a number. And they say, here's our estimate. And I know that given the uncertainty, the things I actually know right now, that's really high precision. And so I'm almost always comfortable saying that's an inaccurate estimate. Now, they may get lucky and get it right, but it's sheer luck at this point. And so I'd rather hear, if I'm asking for an early estimate, particularly on, and I hear a lot of precision where there isn't a lot of knowledge, that makes me nervous. But I also don't want so imprecise that it's perfectly useless. So we're trying to find this balance between precision and accuracy. Though, to be honest, I always value accuracy over I value precision. So my sign here is they can actually describe what level of precision they need to have to maintain accuracy, to maintain the correct value. And we'll see early on that might be a very low level of precision because we don't know a lot yet. But they can tell me this is the precision that we need to maintain to make sure that the correct value is still in there somewhere. As a bonus sign, they can start say, my bonus sign here is, I'll give you a couple really. My first one is that they can tell me when they can increase the precision. That's always a good one. But the other bonus side is watching out for highly precise ones when we don't know it. And this is one you'll probably see very frequently as a software estimation receiver or even a giver, that they'll look at it and go, wow, here's all the details. And then you'll go, well, that's really high precision, and we still haven't know what we're building yet. How'd you do that? Right? So that's your bonus sign. Again, if you have questions on this, feel free to queue them up to Jenny and Jesse as we go along. Area 3. Estimating the work itself, or work estimates. This is a good area to look at, because what we're looking at here is the work itself. What we know about the work changes from very low detail about the work to very high detail, or I like to say knowledge penetration. How much do we really know? Not how much can we guess at, how much we really know. Because what happens often in a project is we'll be out here at this stage, and we kind of know the name of the project, we know that maybe some neighbor features, maybe a key customer, but that's all that we really know. And then we see a team that goes off and guesses at all this stuff down here. They don't know it, they're just guessing. They have meetings, they spend a month and a half guessing at all this stuff, and then they put it in their spreadsheet and they come up with a big old number and say, here's our estimate. Well, what did they really know at that point? Nothing. They didn't know anything. They guessed at a lot of stuff, but what happens in real life? Yeah, you know, right? By the time we get there, it's all wrong. And we've based a lot of decisions on something that was completely made up. So we want to start saying, what do we know and what techniques work well with what we actually know at a time? So early on, there's a handful of techniques that can work well when we only know big blue blobs, if you will. The parametric technique, this is a technique that uses tools and statistical models from statisticians to help you figure out what the estimate might be. But it's going to have relatively wide precision. In fact, anything on a blue blob cannot be super precise and be accurate at the same time. That's just one of those interesting facts of life. We can do structured groups. This is where we have individuals estimate or small groups estimate and then bring them back together to compare and talk about. But my favorite up here is analogy. Analogy basically says, let's find something that we've done in the past that's similar to what we're doing now. And if we can, take historical data from that thing in the past and apply it to the thing now. It's like we're working on project beta or release beta, and we go back and go, well, release beta is roughly the same size as release alpha. How much effort did we spend on release alpha? We'll probably spend a similar amount on release beta. That's a great way of doing it. If we didn't collect historical data, I actually use the structured group technique to help create historical data. That's a great technique, because if you estimate things in the past and then apply them going forward, the estimating things in the past has no political pressure. No one's arguing that the things that are already done should be smaller. They're just looking and going, oh, okay, that's how big it was, and then we'll go that going forward. So that's a pretty good trick too as well. As we move through, then our techniques change. Then proxies become pretty handy. Now, a proxy is a placeholder for all the work. One of the most common proxies in estimation history is the line of code. Now, a lot of people get confused because they start saying lines of code, well, that keeps changing. What actually isn't changing is the amount of overall effort to understand the problem, do requirements, do design, code, test, debug, document. The line of code was just a proxy for all that work, and all that work hasn't changed that much. So lines of code for estimation can still be a decent project. Now, I can give you more lines of code. If you just want to count lines of code, that's a different problem. But we can use it as a proxy. But we can use other things for proxies. We use stories for proxies. We use requirements for proxies. We use features for proxies. I used domain models and classes for proxies. There's lots of things you can use. And then we use that proxy for all the work. And finally, as we get down to the end, that's where expert judgment really starts to take hold. Because it turns out we're not very good estimators as human beings. We tend to be highly optimistic generally. A few of us are really pessimistic, but most of us are optimistic. And when we try to estimate something big like the blue blob over here, our optimism takes way too much bias into that. And so we're actually okay-ish if we estimate very small things. So expert judgment really takes a hold down here. So one of the things I'm watching for is if I'm up here at the blue blob stage again, and someone gives me an expert judgment, I'm going to say, really? That's the only technique you could use out here? Because that's probably wrong. So my signs here, the estimator can describe the technique and inputs for estimating the work itself. What do they really know, right? The inputs are what do you really know? And you use a technique that works well with what you actually know, not what you're guessing at. As a bonus sign here, the estimate uses multiple different techniques. Because what I like to see here is that, hey, I did an analogy, I did a structure group, and I did a proxy, and they all converged around this area. As a recipient of an estimate, that's going to be a really warm feeling that that's a good estimate that I can use. So there's your bonus sign. And again, if you have questions, cue them up with Jenny and Jesse. All right, so let's find estimate area 4, estimation bias. What is this all about? Well, in this area, I'm looking at what biases people bring to the project. Because it turns out that human beings tend to be optimistic. That is, they tend to give me an estimate. Well, back up. If I ask them for a single point estimate, say, how long is that going to take you? What I usually get back is an estimate that has roughly a 25-ish% likelihood right there. So we're right down our scale. If I ask someone for their worst case estimate, what they usually give me is either a 70 or a 90, often closer to 70 because, again, they're still optimistic. But those are the points they often give me. So what are the odds of that really happening? Because what I typically do is I walk around from person to person, say, how long is that going to take? How long is that going to take? How long is that going to take? And then I combine them together. So what this probability wheel is going to try to answer for me is, if I were to spin this probability wheel 10 times, spin, 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 spin. If I were to spin this 10 times and add up those threes together, what are the odds I will get various values? That I'll get 10 or less, or 20 or less, or 55 or less, 70 or less. So obviously 10 or less, not going to happen. But here are the odds. I had a math statistician calculate these for me. And you can see right now, if I went around to individuals who are optimistic and asked 10 of them what their estimate was, and they add them together, I would get a probability that the overall combined number, what's the chance of hitting that? 0.018%. It's not going to happen. But what if I went around and said, give me your most pessimistic number? And I said, maybe it's a 70 or 90. You can see I have a 95 or even 99.9999 cents. That's humongous odds. That's going to be a big, big number, especially the 99.99999. We're getting close to infinity and beyond. And no one wants to hear that number. What I really need, if I'm combining estimate and how I'm dealing with bias, I got to find a way to get to this 55-ish kind of number, because that's the only one that maintains the same amount of variability. I need to try to get to that 50-50 nominal estimate. I've got to find ways to deal with bias. And so if you take a class on estimation, they should be able to describe different ways of dealing with bias. There's lots of different techniques you can use. So my sign here is, can they describe how they dealt with bias, whether underestimation bias, which is the most common, or the occasional overestimation bias, which is far less common. But they got to say, here's how we dealt with it. So they don't try to give me a number which they combine from lots of optimistic biases, which gives me a thing that has almost no chance of happening whatsoever. As a bonus estimate, they can actually do two things. They can say, you know what, because we know this bias, we actually know where the higher commit point is, because we asked for a more worst case number. But we also want to track against that 50-50. This is a really important concept. The idea is that externally we commit to one number, but we track internally to a different number. Because if we track to the commit number, then we got Parkinson's law at work. But if we track against the 50-50, even if we go over some things, which we should do because it's only 50-50, we still can deliver on our commit. So to me, that's a great bonus sign when they can start talking about those two different numbers. That tells me I've got a pretty good estimate. All right, sign 4, then we're on to sign 5, special cause. Now there's two types of variation that's going to impact us. One is special cause variation, the second one is common cause. So let's look at special cause first. What special cause variation is really talking about here is that there are things that normally do not happen, but could happen. They're not totally off the wall, but they usually don't happen. These are things we often call software project risks. You can see I have a couple risks listed here. And what you do with software project risk in risk management is you estimate two things. You estimate the probability and you estimate the severity. So for example, risk 1, we said it has a probability of 50% and a severity of 80. Right? And we go through and there's estimation techniques for that. What you can do though, if you've estimated these fairly well, you could then multiply these two together and get a thing called the risk exposure. The risk exposure is another 50-50 estimate, just like we're trying to do with the nominal of the work estimate. We've already talked about the work estimate, how to get that, but now we're adding to this special cause or risk. And we get another 50-50 estimate. And we add up all those and we get this thing like 450 here. So how does that impact my estimate? Well, I got my estimate bars here, and I got my work estimate itself. So there, we make an estimate of the work itself. Then I go through and I add up all my risk exposure, and then I shift my work estimate. This is what I call my risk exposure shift. That the work itself, regardless of all the risk outstanding, should take this distribution line, this distribution, but risk exposure just sort of shifts it all to the risk side. Now, what's nice about this is I can start using this risk exposure as sort of a buffer, right? I still got my commit number, but I may have to put a buffer on top of that because of risk exposure. Now, what a good project manager or a good leader will do is they'll find ways to draw down that risk. Risk 1, instead of being 50% likely, maybe we only make it 25% likely. Or risk 2 being a severity of 100, make that a severity of 20, which then again buys down the risk exposure. But we'll have to add stuff to the work itself to do that. So I'll see that still shift a little bit because we'll add more work to the work estimate. So what are my signs here? My primary sign is the estimator can describe the technical and the technique and inputs used with estimating special cause variation. What does that mean? That means that we actually went through and did good risk management. That's the technique, right? And we used that as the input. We did a 50-50 estimate to come up with this. And as a bonus sign, they're actually looking at new work we can do to buy down that risk. Because one of the sad things we've seen in projects throughout the years is that the unplanned work, the work we didn't expect to do, not the work estimate, but the unplanned work is usually as big or bigger than the planned work. And so what risk exposure does is start talking about how big that unplanned work might be. And then we start planning work to really buy that down. So that to me, that's a bonus sign that I've got someone involved in the estimation team that's really on the ball. All right, so if that was special cause variation, we should go then look at common cause variation. Common cause variation is a little different than special cause. Special cause is what happens to you rarely. Common cause is what happens to you most of the time. And we express common cause, I think one of the best ways to express it is with the cone of uncertainty. This is a variation of the cone that Steve McConnell put in his book, Rapid Development, a little bit on his book, also a software estimation. And I've modified it again as well. But the idea here is that if we look at time down here on the bottom, right, and time's going this way, okay, very early in the project, we have a lot of uncertainty, a lot of variation, lots of things that may or may not happen. And that uncertainty, which we often call inherent uncertainty, is driven by all the decisions we haven't made yet. The primary decisions are about what the heck are we going to build and how are we going to build it, right? Who's involved in this project, who's not? Lots of early decisions. This is like your commute to work. I got to be a little careful here because right now my commute to work is from my bedroom upstairs down to my family room here, which is not that far. But I could be distracted. I may have to deal with our foster dog. We're taking care of a dog for an elderly man who can't take care of it right now. So I might have to deal with a foster dog, or I might want to have to clean up something in the kitchen. I don't know anytime I do that walk exactly how long it's going to take. This is more obviously the case when I used to drive to work, right? The drive each day has specific traffic lights that may or may not I may or may not make at the one time. Traffic patterns change by day. Rainy days are different than sunny days. All these different things until I start actually doing the drive, I don't know on that particular day. I know generally within a range how long it takes, but I don't know on any particular instance how long that's going to be. And that's what common cause variation is all about. Common cause variation says the process itself drives variation. Now in our agile teams, when we're doing 2-week sprints, this is pretty easy. This is like moving my house. This is like going back to my bedroom. The variation is going to be really, really small because there is a lot of things that could go wrong. But if you look at overall releases, something bigger than 2 weeks, it gets to be higher variation again. So the sign I'm looking here for a good estimate, the sign I'm looking here is the estimator can describe, again, the technique and inputs when estimating common cause. How do they know what our common cause variation is? Now, it would be perfect if they said, hey, we collected data on the last few estimates we made and how far off they were from what actually happened. We can draw our own cone. That'd be a great technique and input. But if they can't do that, they could still say, hey, we looked at industry data. We've looked at some other sources. We helped those. We used information from those to help us understand what our variation might be. So, but at least they understand that, yes, inherent uncertainty exists, like the cone of uncertainty, and we've got something to do with it. As a bonus sign, right, they can actually draw our cone, or at least something that looks like a cone that's applicable to our work environment and the kind of things we're doing, and say, yeah, we're right about here. Right? Because if they can do that, that shows me they have a good understanding and they've incorporated the right amount of uncertainty into their estimate, which is going to basically be reflected in their amount of precision. All right. And finally, sign 7, what area are we going to look at here? This is where how you can help me use this estimate, because I, as a planner, need to use this estimate to make decisions. That's what I want this estimate for. I don't want this estimate as a strong predictor of the future. I mean, if I had that kind of technique, I'd have people doing lottery numbers for me. I wouldn't asking for how long a work effort would take. But what I am looking for is I need to make decisions about how to allocate resources, how to allocate funding, how to prioritize things, and I need these estimates to make decisions. And you need to help me understand what I can do with these estimates. So here is our curve again. So what I need to do is tell me, what can I do with the estimate you're giving me? And I think there's 3 main estimates that you can give someone. One of them is what I call the external commitment or the commitment estimate. The commitment estimate is saying, here's a point in the curve where I feel comfortable committing. And this is often around the 80-ish% area, right? Where 80% of the area is over here and 20 is over here. That's the area that I don't mind committing to. Because if I commit to this particular point, that says, yeah, I have a pretty good chance. It's not so extreme that's so big, but it's a pretty good chance of doing it. Now, I usually can't do this external commitment point very early in the project because the cone is so wide, right? My inherent uncertainty is so wide that even at 80%, that's a really huge number. It's not very useful at that point. But when the cone narrows, that's where I can usually make this one. And so I can tell people, here's where you can make external commitments. The next point that's often used is what I call my tracking or planning point. This is what I can do any time in the project. What I do with the tracking planning, I say, this is the point that I think you can use. And this is close to that nominal point, the 50-50 point. This is what I want to track the team to. And again, as I said earlier, we may externally commit to something, but I don't track to that. I track to the training planning number because if I track to this number, that gives me high confidence I will be able to meet my external commitments. If I track to just the external commitments number, Parkinson's law, right? So I don't want to do that. And there's one other point here that's really interesting that we don't use as much, we use all the time, but we don't acknowledge. And that's the ambiguity checkpoint. This checkpoint is about 25% probability. That is 25% on or before and 75% chance of going over that number like it was wishing by in the night. So what good does this one particularly do? Well, we actually use this one a lot. We use it when we're doing story pointing and task estimation on agile projects. When someone says something is 8 story points and someone else says it's 3 story points, they're not saying this is actually this many units of real work, or it's going to take this many days to build it, or this many staff members. No. All they're saying is, hey, I think it's this much work. And someone else says, no, I think it's this much work. And when we say 8 and 3, we're saying we don't see the work the same way. We have ambiguity. And what we need to do is work as a team to reduce that ambiguity. So we all agree on the number. And we all agree 8. Do we care if it's really an 8's worth of work? No, we don't care at all. I think this is even better illustrated on task estimation. When an individual estimates a task and say, I think this is 4 hours of task, they're doing an ambiguity check. Because the rest of the team should look and go, yeah, from what you described, that sounds like 4 hours. If I as a team member look and go, What do you mean 4 hours? That looks like about half an hour's worth of work. What are you talking about? We have ambiguity. We need to clarify this out. Do we really care if it takes 4 hours or not? No, because we're not making external commitments. We're not doing tranning or placking. We're just checking for ambiguity. And we're using the ambiguity point here because that's really easy. That's where our guts want to go. That's where our natural human tendency to estimate is. And so if you use it that way and not as tranning or placking, not as an external commitment, then it works great. The moment you start changing it into those other ones, then you're in deep trouble. So the sign I'm looking here for in terms of planning is, can the estimator state how the estimates can be used to support the planning decision? Are you giving me a commitment at this point? Are you giving me a tracking and planning this one? Or are we only doing this to help us identify ambiguity as quickly as possible? So whatever one that is, I can use that as a planning thing going forward. And your bonus sign here, the estimator actually has a procedure, so I know what to do with these numbers they're giving me. I don't have to even ask the question. We're just following our standard procedure. Oh, we're at this point in the project. These are the kind of estimates you give me. Here's what I can do with them, right? That makes the whole thing go much, much easier. And I can have confidence, hopefully, that both of us are following that procedure. So I think those are the areas work with. So let's digest this all here in our summary so we get this done and get it into our system. What were those 7 key signs again? Our 7 signs that we've received a good estimate, that this is a good estimate. Sign number 1, the estimator can name where it lands, the estimation probably distribution. The key here is that they recognize there is a distribution and they're picking a point on that curve. So I, as a planner, as a leader, can understand how much risk we're at when we pick that number. The second one is they can describe the level of precision that makes sense here. What I'm actually looking for here more is that we have the wrong level of precision, that they give me a number that's too precise for what knowledge we really have. That tells me they're usually just typically making stuff up. However, I do not want, from here to an infinity, that's way too much imprecision at that point. I also want to know, can they describe how the technique inputs when estimating the work itself? Because the first estimate I want to see is the work itself. How much work is actually there? We're going to deal with common cause and special cause variation next, but just give me the work. How much work is really there? And did you do a good job looking at the chunking of that work for what we actually know at this point? Because when they're looking at the technique here and inputs, I'm really looking for what is knowable, not what are we guessing at. And then I want to see how we dealt with bias, right? Because we know that human beings are biased, typically to underestimate. Did you have something in there to deal with that bias? Did you ask 3-point? One technique might be 3-point estimation to help people deal with their own bias. Or you might have a special fudge factor that you've always applied to particular people because you always know they're over optimistic, or maybe occasionally they're just cynical and always sandbag it. Then we're going to look at the techniques inputs for special cause variation, right? And here's, are they doing a reasonable job of risk identification? Are they doing a reasonable job at risk estimation in terms of probability severity? And have they calculated risk exposure? If they haven't done that, how do I know that their buffer? I mean, I was with an organization just a while back and they said, well, we just took our number and we took 20% and added that as buffer. Where did they get 20% from? Okay, it's a rule of thumb, but how does that tie back to anything we're going to do to actually buy that down? I can't do that. I need a risk list to actually say, how do I buy this stuff down so I know I'm doing the right kind of work? And then we have to look at the process itself. So we're looking at the techniques inputs for common cause variation. How are we looking at the process? Are we changing the process in any way? Right? How do we make it so that we can slowly work down? This is where the idea of inspect and adapt and continuous process improvement is always trying to lower the variation. That's what it was about from the very beginning on any kind of process improvement. That's what Deming did decades ago. And finally, are you giving me the information I need to help support the planning decisions I need to go into? Because I need to know what I can do with this estimate. Do not give me a commitment estimate when I want to do just ambiguity checking. That means you're putting way too much work into it. And don't give me a tracking estimate as a commitment, because you're going to go past that probably because it's only 50-50. On top of that, I gave you the 7 bonus signs. The 7 bonus signs were just other things you can be looking at here to help make sure that you have a good estimate. And one of the things I really like on this list personally is number 3. Number 3 says, are you using multiple techniques? Because I think when people are using multiple techniques, that's, like I said, gives me such a better warm feeling that we've got a good estimate here than they just had a spreadsheet of craziness that I have no idea what's really going on, where most of the stuff in there is just made up at the moment and has no bearing on what's really going to happen whatsoever. But the other one I still have here is number 2, watching out for the high precision. I think these are all really important. So those are my 7 different areas to look at with my 7 bonuses. So now it's time to do some Q&A. But before I go on that, I just want to point out that you can get this talk later on. You can replay it. It's in our on-demand environment. Also in the on-demand are all the previous Lunch and Learns. And also up there are our courses, seminars, and Steve McConnell talking about understanding software projects. You can also find out more Lunch and Learns at construx.com/lunch. We'll be seeing Steve McConnell come back next week. Steve Talkie, a good guy, is going to be talking on Thursday. So drop in and put those on your calendar as well, or share them with your friends if you think they're interested. So now I'm going to bring in Jenny. Jenny, you standing by?
I am standing by, Earl.
All right. Did we get any questions in the queue?
Yes, we did. Thank you for that very interesting, thought-provoking conversation of different signs to look for in your estimates. I'm certain some folks will go back and look at their own estimates again through a new lens after this.
Yeah, that's really interesting when you think about it that way, right? So not only for the consumers, but if you're preparing, when you can say, am I exhibiting any of these signs?
Correct. Absolutely. So one question we had, you talked earlier about different estimation techniques happening at different points as you have more and more knowledge about the problem and the solution. There was a question kind of across the board of who are the best people to include while estimating.
Right. So one of the things I like to talk about is, first of all, in my estimation class, what I do is I say there's like 4 or 5 things that you go through in an individual estimation process. And one of the questions is, what are we estimating? Are we estimating the entire project? Are we estimating a section of the project? Are we estimating one sprint? Are we estimating just one work item? And the team I want to have there is the people closest to the level we're estimating. So at the project level, for example, I will want to have project leaders estimating because they're thinking about project as a whole. Now they go talk to other people, but they're the ones I want as the estimators. If we're talking about an individual story, for example, I want the team working on that, the development team, because they're the ones closest to that level. If it's an individual task, I want the person working that task to be the primary estimator and maybe other people working with them because they're the ones closest to the work. So you just have to be clear about first, what are we estimating? And then what is the level of role that's closest to that work and have them do that estimating. Is that kind of where they were headed, Jenny, or is there something else there?
No, I think so. I think so. And yeah, I mean, definitely you'll see a shift in who's doing the estimation as you're looking at and estimating different things. So that really resonates with me.
Right, because have you seen that in your own world too?
Yep, absolutely. Yep. So do you think all the 7 areas are equal, or do you think that some of those areas cause the most pain or happen the most often?
I think they are somewhat pretty much, well, they aren't equal. I think there's probably 2. I want to say they're all equal because they're mine. No. I think the most common error that I see in estimation when I go out to visit shops is that they've gone through and what they typically do, let me sort of sketch this up here. What typically happens is that a big boss will come along and say, I need an estimate. And they'll say, well, what we have so far is the name of the project. And we have some top features, just the top ones. And we have a budget, because we always sort of come up with a budget and sort of time frame. And they say, give me an estimate. And so what we go do is we open up our spreadsheet of hell, and we try to go through and identify all these tiny little tasks that we're going to build. We're going to do this, and we spend months doing this. Well, all this stuff down here is made up, right? Yeah, it's made up with intent. I mean, it's like stuff we've done before, but we really don't know because all we know right now is this stuff over here. We don't know anything else about this stuff. And so all this is made up. And then they come back from all that with a single number. Here's our estimate. And then this person takes and goes, okay, and they start telling the world about this number. Or they start griping and saying, well, that number's so big. Didn't you know our budget? Can't you bring it down to something within our budget? And people go, oh, okay. And back we go. So it's really two things from that list of 7 signs. One is not understanding the precision, right? Because we're coming back with a single number, which leads these people astray. And 2, the other one is trying to estimate on things we don't know. Because to actually lower the cone of uncertainty, here's our little cone, you actually have to work the cone. How do I know how long does it take me to get to work on a certain day when I actually drive to work or even walk down here? I start walking, I start driving, I see what the traffic's like. If I made that light or not, I see if I got past those train tracks or not, right? I learn all these things. I see if the bus is delayed or not, right? Once I know that, boom, I start to drive down. But we only base things on things we know. So while the 7 may be popular, I mean, I think there's all 7 of those. The 2 biggest one is watching the precision problem, particularly early on. I mean, particularly early on ones, the precision problem and the making up estimates on things you don't know. Because one of the things I like to tell people is that a good estimate should take 15 minutes or less. Right? Because if you have a technique and you already know the things, it really doesn't take that much longer. If you're trying to make stuff up, then it takes a long time.
We used to joke about the cocktail napkin swag to the product manager when all you knew was the name and like 3 out of who knows how many things were supposed to be delivered.
Right. And often if they put the imprecision around that was appropriate, it might have been an accurate estimate. It would have contained the right value in there somewhere, but they gave it as a single point number and then the swag was laughed at.
Yep.
Which brings me to the other question that's up here is what about the no estimate movement? And the no estimate movement has a valid point in some ways. I like to think the no estimate movement, if we think about our little drawing again here on our estimation curve, right? The no estimate movement is a confusion between Agile is using this point over here for ambiguity and commitments. Right? It's those two that are getting confused because no estimate says these should not be happening. In fact, even the planning estimates I thought it shouldn't be happening in the sprint team. It's not their problem. They should be only saying, do we understand the work the same way? So we get into sprint planning and end our sprint plan. We all have an agreement of actually how we're going to build this thing. So I think that has some validity in terms of estimating at the small, but it doesn't have validity in estimating at the large because my stakeholders are still having to make decisions out here. And if you don't give them what they need to make those decisions, then they're kind of in trouble and they're going to ask for it anyhow. They need that information because an estimate is just information we're giving to the business so they can make better business decisions.
Sure, absolutely. Many businesses live and die by their ability to have that information.
Right. I mean, how else do you start saying, do we need to hire more people or not? Well, someone's got to estimate something. Oh, yeah. Any other questions in the queue at the moment?
Yeah, you were talking about how a good leader will buy down risks to, you had that example of 100% and being able to buy that down to maybe more like 50 or even 25%. Do you have any suggestions or examples of how people can buy that risk down?
Well, interesting enough, a lot of people are already buying down risk. They're doing what I call smart work, right? Code reviews. Why are we doing code reviews, Jenny? Because there's a risk that there might be defects, right? And so we add extra work to find it. Testing is a buy down strategy. So we're already doing smart work already. People do this, but you can actually start saying if people are pushing back saying we're not going to do code reviews anymore. You say, oh, really? So what's the risk of us having defects in this code? If it's more than trivial, it's like, well, the cost of doing review versus the cost of finding that defect afterwards, ouch, kind of thing, right? So some other more examples, prototyping is a very common one that we're seeing more and more of these days. Getting better user stories, actually spending more time actually getting really measurable, testable acceptance criteria is another great one. Doing TDD is a classic buy down strategy, right? doing things the way they work. I'm working with a company right now who has this phase. They were investing relatively in phase to massively buy down the uncertainty and therefore the risk of committing to a much larger project. And then we're talking tens of millions of dollars here. So instead of trying to commit to tens of millions of dollars up front, they're going to spend $750,000, a tiny fraction, less than 10%, to buy down much money. So they don't have to have a precision of 20 million. They can have a precision of 3 million, which is a lot better for that kind of organization. Have you seen stuff like that, Jenny?
Yeah, absolutely. Thinking about what risks are going to hit you most, right? Is it understanding the problem? Is it a technology risk and trying to figure out what the right technology bet is? Just making sure that you're, like you said, doing prototyping or doing spikes or doing some form of investigation throughout to really help you not have, as you like to say, the egg roll off the table and go kersplat.
Right. And the other thing there to think about too is that when we talk about this in the risk management class, that you can get on demand or virtually live with someone like me, is limiting the number of strategic risks. There are risks that you're taking just because you want to advance your product, like going to a new platform. But you also don't want to go to a new platform and learn a whole new methodology at the same time. That's bringing on two strategic risks and really making your project much more difficult. You say, well, we'll go to the new platform, but we'll use the older methodology that we know actually how to execute right now. Right? That's another sort of way to buy down risk.
Great. Well, that concludes the Q&A.
All right. Well, if you have additional questions for us or things you want to learn, you can contact us at hello.construx.com or myself personally at earl.beede@construx.com. You can find more of these at construx.com and lunch. We're happy to hear from you and learn about things that you're doing. So drop us a line there. Check out our on-demand. And remember, Steve Talkie is coming back on Thursday with another Lunch and Learn for you then. And then Steve McConnell and Jenny, I think you're up next week too, right?
That is correct. I am.
Excellent. So Jenny will be up next week too. What's your topic?
Scaling dysfunctions.
Scaling dysfunctions. So check in Jenny next week. I think you're Thursday, right, for scaling dysfunctions.
That's correct.
All right. So we'll hopefully see you all again then. Enjoy the rest of your day.